We've talked about lots of services, DNS, DHCP, NTP, and others. As an IT support specialist, it's important to understand how the programs that provide these services operate, so that you can manage them and fix any problems that pop up. These programs run as background processes, also known as daemons or just services. This means that the program doesn't need to interact with the user through the graphical interface or the command line interface to provide the necessary service. The operating system ensures that the program is running. Each service has one or more configuration files that you as a system administrator will use to determine how you want the service to behave. Some services may offer interactive interfaces that allow a user to edit the configuration and to inspect the current status or the usage history. Other services may just rely on the system infrastructure for this, which means you'll need to edit the configuration files yourself. You'll have to know how to start and stop the service and how to go through its logs to see any current or previous activity. Services are usually configured to start when the machine boots, so that if there's a power outage or a similar event that causes the machine to reboot, you won't need a system administrator to manually start the service. If you want to decide yourself when the service starts, instead of starting upon boot, you will need to change the software configuration to make it start when you want. Similarly, services are usually configured to restart if they crash unexpectedly. If this is not how you want to set up, you may need to change the system configuration that handles these properties. There are lots of services out there, and each may require specific knowledge regarding how to configure it, and when and how to use it. But the general concepts related to managing and configuring services are the same across the board. In the rest of this lesson, we'll look at examples of how to do this on both Windows and Linux. As a system administrator, you will need to know how to look at the status of a running service and how to stop, start, and restart running services. The exact way to do this will depend on the operating system you're using, but the concepts are the same. Let's look at a very simple service, Network Time Protocol, NTP. We've called out before that NTP allows machines to synchronize their clocks. Ubuntu installations include a daemon that runs on the machine and is in charge of synchronizing the clock using NTP. We can check that there's an NTP daemon running on this machine using the service command service NTP status. We can see that there's an NTP service and the system tells us it's running. This service is keeping our clock on time without us even realizing it. If at any point it detects that the clock has drifted, it adjusts the time in a very small increment. It will add or remove 0.5 milliseconds per second until it reaches the desired time. It uses very small increments so that other services which depend on the clock to perform their tasks won't be affected by a sudden adjustment of the time. Under normal operating conditions, a computer clock will only see very small drifts from the standard time. So these very small adjustments make sense. If the daemon detects the time has changed more than 128 milliseconds, it assumes that something else is going on and will not interfere. Let's test this by manually modifying the date of the system to a date in the past. So I'm going to go ahead and type in sudo date and give it a specified date, 2017 01-01 space 00:00:00, and that specified date, hit enter, and then type in date. We've set the date to January 1st, 2017 at 12 a.m. If we check the date after a few seconds, it will still be set to January 1st, 2017, a few seconds past midnight. It does not get adjusted. The NTP daemon saw the change, but since it's more than the 128 millisecond threshold, it's not adjusting the clock. So how do we make it catch up to the present? There is an option in the NTP daemon that allows it to drastically adjust the clock when it's starting. This is because the daemon is expected to start very early in the process when the machine is booting up, so there shouldn't be any time-dependent services running at that point. If we manually restart the service now, we'll see that the date and time get adjusted. So let's type in sudo service NTP stop, Okay, so type in date sudo service ntp start. And then type in date. And then enter. We use the stop action to stop the service and the start action to start it back up. Immediately after starting the service, we can see that the date and time are set back to the present. We use the sudo command to stop and start the service because any user can check the status of the service, but only an administrator can cause it to stop and start. An alternative that's available in most services is the restart action, which does a stop followed by a start. Let's see how that one looks. First, let's set the date back to January 1st, 2017 at 12 AM, and then we'll restart the NTP service. So I'm gonna type in sudo date, specify the time. So 2017 00 01 000000. Hit enter. Then hit date. Then hit sudo service ntp restart. Then hit date. Now you've seen how to check the status, start, stop, and restart services in Linux. NTP is a very simple service, but you can also use these same commands to manage much more complex services. Like Linux, Windows also allows the system administrator to manage the services that are running on the system. For this example, let's look at the Windows Update service. This service is in charge of detecting software updates for either the operating system or other installed programs, downloading them, and having them ready to be applied to the system. Let's get the status of the running service using the get service command. So I'm going to go ahead and open PowerShell. And I'm going to go ahead and type in get service. I'm going to type in the shorthand form for Windows Update Service, which is this. So WUAU serve is a short name for the Windows Update Service. We can see that the Windows Update Service is running and can get more information about it by running this next command, which is going to be get service WUAU serve, and then I'm going to type in format list and asterisk. This will show us what type of service it is and how it's configured to run. It's a good way to get additional information on a service you're interested in. As with Linux, any user can query the status of a service, but only administrators can start or stop a service. If you try to do the next steps with a normal user shell, you won't be able to run the commands. Now let's try stopping the service and then checking the status. For this, I'll open an administrator PowerShell and run the stop service command. So I'm going to go into my start, and instead of clicking on it, I'm going to right click and then type in run as administrator. And hit yes to the security control. So now I'm going to go ahead and type in stop service WUAU serve. Next I'm going to type in get service WUAU serv serve. So this service has been stopped. In order to start it back up, we execute the start service command, which I'm going to do start service WUAU serve to start the service. And then I'm going to type in get service to show that the service is now running. Finally, you can list all services that are registered in the system using the get service command. We can also perform these same actions graphically using the Services Management console. So I'm going to go ahead and click on Start. Services. This console shows us all the services in the system. The ones that are running will say running in the status column, while the ones that aren't running won't say anything in the status column. We can find the Windows Update utility at the end of the list. We can stop it by right-clicking on it, and then hitting stop, and then right-clicking again, and hitting start. And there you have it. That's how you get the status, stop, and start services in Windows. On top of knowing how to query the status, stop, and start services as a system administrator, you'll have to know how to configure services to meet the needs of your organization. For example, if you're running a DNS server, you'll need to configure the DNS zones that you want to serve. If you're running a web server, you'll need to configure the different sites and web applications that you'd like to have enabled. And in general, you'll want to apply any specific security and backup policies to all your services. The details will depend a lot on the operating system and the service. But let's talk about the basics that you'll need to know for all services. Most services are enabled as soon as you install them. These are programs that are shipped with the defaults that are good enough to safely start serving right away. But not all services can provide default values that are suitable for everyone. In some cases, you will need to edit the configuration files before the service can go live. On Windows, most of the configuration is stored in the registry. This can be modified using graphical wizards or using the set service command. On Linux, the configuration files for the installed services are located in the etc directory. And while some software may ship graphical configuration editors, you typically have to edit the configuration files with a text editor. Let's experiment with a simple FTP server called VSFTPD, a service that gets enabled by default when installed. So I'm going to go ahead and type in sudo apt install VSFTPD to install the service. Once it's done installing, the service is already running. We can query the status of the service by running service VSFTPD status and see that it's running. This tells us that the service is already running. We can also verify that it's running by connecting to the FTP server with an FTP client. To do this, I'm going to go ahead and type in lftp localhost. LFTP is an FTP client program that allows us to connect to an FTP server. When we tell it to connect to localhost, it'll try to connect to the FTP server running on localhost. Now, let's try to run the ls command to list the contents of the current directory. So I'm going to type in ls. And then type in exit. This is failing because it's requiring a username and password, and we aren't providing them. It makes sense that the default behavior of the FTP server is to be locked down. If we really want to enable anonymous connections, we'll have to do that explicitly. Let's modify the configuration file to allow anonymous connections. To do that, I'll edit the configuration file for this service that's located in the etc vsftpd config to change the anonymous enable setting from no to yes. So I'm going to go sudo vim etc vsftpd config. This will open up my config file. And I'm going to go ahead and change in the anonymous enable from no to yes. Save my configuration file. By changing the value of the anonymous enable setting from no to yes, we're telling the FTP server program that we want to allow anonymous connections. We've made the change, but we aren't done yet. If we try to connect again, ls will still fail. ls. It failed. I'm going to hit exit. This will also happen with other services because most services read their configuration when they start and then keep it in memory while they're running. In order for our service to reread the configuration, we need to tell it to reload. Reloading means that the service rereads the configuration file without having to stop and start. That way, ongoing connections aren't interrupted, but new connections will use a new configuration. Let's do this for our FTP service. So I'm going to type in sudo service vsftpd reload. Once we've done this, we can try to connect again, and this time, executing ls will succeed. Let's see. It worked! We've now seen how to start, stop, restart, modify configuration, and reload this configuration for Linux services. Let's look at how you can do something similar using Windows. For this example, we'll be using Internet Information Services, the feature offered by Windows to serve web pages. First, we'll need to enable this feature. We'll use the Turn Features On and Off option in the Windows control panel. So I'm going to go ahead and click Start, Control Panel, click on the Turn Windows Features On and Off. This opens the Server Manager, which we can now use to enable Internet Information Services. So I'm going to go ahead and click on Next, Next again, and Next again, so a total of 3 times. I'm going to go ahead and scroll down and look for Web Server IIS. I'm going to click on that, and then I'm going to click Add Features. Click Next. Click Next again. Next again. Next again. And then hit Install. I've selected the Web Server option to have this service enabled on this Windows instance. It's now installing all the necessary pieces to enable a web server on this machine. It's now done installing. When we close this window, we notice that there is a new option on the Service Manager called IIS. We see here that we have an IIS service running on this server. We can configure this service by right-clicking on the entry and then selecting Internet Information Services Manager. Then I'm going to expand on our server and then click on Sites. These are the websites that are handled by this service. Currently, there is only one called Default Website. Let's see what this website looks like by navigating to localhost. So I'm going to go ahead and click on Internet Explorer and type in localhost. Great! Our server is serving the default website. Now let's add a different website to it. We go back to our Windows Information Services. I've created an example site and stored it in my Documents folder. Now, I'll copy this example site into the inetpub directory, which is the directory normally used to serve websites when using IIS. So I'll hit copy. Then I'm going to go into the inet directory, just C, :/inetpub. I'm going to paste that example folder from my documents to the inetpub directory. And then hit continue, security control. Alright, I've copied my website. Now let's enable it in the IIS Manager console. So let's go back to the console. I can add a new website by right-clicking on the list of websites and selecting the Add Website option. I'm now presented with a bunch of options that I need to fill in. Let's select Example as the name of my website. Let's select the folder that I just copied as the physical path for the website. Finally, let's select 8080 as the port. This last one is so that the default website can run in the default port, port 80, while our example website can run in a separate port. Alright, I set up the new website. IIS tells me that the website is already up and running. Let's see if that's correct. I'm going to go ahead and click on Internet Explorer, type up localhost, and type in :port 880 and hit enter. Success! We've added a second website to our web server. We've now seen how to install, manage, and configure Linux and Windows services. In the next quick lab exercises, you'll be able to try these actions yourself. Have fun! In In large enterprise deployments, you'll probably have different programs serving each of the networking services that we covered in this module. In smaller setups, you may be better off having a centralized solution that handles all services. Let's look at Dnsmasq, a program that provides DNS, DHCP, TFTP, and PXE services in a simple package. This will let us do some hands-on configuration of these services, even if it's not as complex as other networking solutions. Let's start by installing Dnsmasq in this machine. So I'm going to type in sudo apt install Dnsmasq. Once we've installed Dnsmasq, it's immediately enabled with the most basic functionality. It provides a cache for DNS queries. This means that you can make DNS requests to it, and it'll remember the answer so your machine doesn't need to ask an external DNS server each time you make the query. In order to check this functionality, we'll use the dig command, which lets us query DNS servers and see their answers. So let's ask our DNS server running in localhost for the address of www.example.com. We do this by running dig www.example.com at localhost. The part after the @ sign indicates which DNS server we want to use. Here, we have the reply from our query. Our DNS server is telling us the IP address for the domain example.com. How do we know that this query was actually answered by the service the machine is running? We can run the service in debug mode so we get more information about what's going on behind the scenes. This isn't how you would normally run the service, but it's useful for understanding what's happening. So let's stop the Dnsmasq service that's running and then start it in debug mode. So now I'm going to type in sudo service Dnsmasq stop. Then type in sudo Dnsmasq with the D flag and then pass the Q flag. By passing D and Q, we're telling Dnsmasq that we want to run it in debug mode and that we want it to log the queries that we execute. When it starts, it prints in the compilation options that are enabled and the configuration files that are used. Now, we can query it again with our friendly dig command. If we run the command again, we'll get the same answer and we'll see the debug output in the Dnsmasq console. So in my second console now, I'm going to go ahead and type in dig www.example.com at localhost. This is showing us that our Dnsmasq service received the query, forwarded it to the configured DNS server, and then replied to the original machine. If we query for the same hostname again, we'll see that instead of asking the other DNS server, Dnsmasq replies with the cached query. So now my second console, I'm going to type in, again, dig www.example.com at localhost. So if I hit enter, for now, Dnsmasq is operating as a simple caching DNS server, but we can make it do more than that. For example, we can give it a list of hostnames and IPs and have this service give authoritative answers for them. You might remember that when trying to resolve a host name to an IP, there can be servers that store the information about the mappings, which can then provide the authoritative answers, while other servers will only be able to forward and delegate the queries to the server that have the information. These files have the same format as the etc host file. I've created this file that lists the internal host that I want to be able to resolve. So I'm going to type in cat myhosts. As you see, it's a very simple format. You just have to list which IP is associated with each host. We use the H parameter to tell us Dnsmasq that we want to include this list in the information being served. So I'm going to cancel this, clear, and now I'm going to type in sudo Dnsmasq dq h my host. Now that we have our list of hosts loaded, let's query it with dig. So now, for my second console, I'm going to type in dig oxygen.local at local hosts. As Dnsmasq is authoritative about this host, there's nobody to forward the question to. It also lists which file it's using to get the information. Neat, right? Finally, let's see what the output looks like when we ask it for information that it doesn't have. So I'm going to type in dig hydrogen dot local at localhost. We see that it replied that the authoritative servers are the root servers, but that it couldn't find any results. And what did the running Dnsmasq say? Since the requested name isn't in the list of hosts known to our DNS server, it forwarded the query to the configured DNS server. The reply for that was NX domain, which means non-existent domain. While Dnsmasq is as simple as it gets, you've now seen what a DNS server looks like in action. Cool, right? We've seen how to use Dnsmasq to serve DNS queries, but as we mentioned before, Dnsmasq can also be used for other networking services. Let's look at how it can be used as a DHCP server. A DHCP server is usually set up on a machine or a device that has a static IP address configured to the network interface which is being used to serve the DHCP queries. That interface is then connected to the physical network that you want to configure through DHCP, which can have any number of machines on it. In real life, the DHCP server and the DHCP client usually run on two separate machines. But for this example, we'll be doing a simulation on one machine so that you can experiment with a similar setup in the upcoming quick lab exercises. In this machine, we have an interface called ETH_SRV that's configured to be the DHCP server's interface. So now I'm going to type in IP address show ETH_SRV. This command shows us that this interface has the 192.168.1.1 IP address. The /24 part indicates that this IP is in a network that goes from 192.168.1.0 to 192.168.1.255. If this isn't clear, you may want to review the lessons on IP addressing in the networking course. The interface also has an IPv6 address configured, but we won't go into IPv6 for this example. We also have an interface called ETH_CLI, which is the interface that we'll use to simulate a client requesting an address using DHCP. This interface doesn't have an IP configured yet, so I'm going to type in IP address show ETH_CLI. We can see that this interface doesn't have an IPv4 address configured. We'll change this by using our DHCP server. To do this, we need to provide additional configuration to Dnsmasq. There are lots of things we can configure. We're going to use a very basic set of options. Let's look at the configuration file. So I'm going to type in cat dhcpconfig. The interface option tells Dnsmasq that it should listen for DHCP queries on the ETH_SRV interface. The bind interfaces option tells it not to listen on any other interfaces for any kind of queries. This allows us to have more than one Dnsmasq server running at the same time, each on its own interface. The domain option tells the clients the network's domain name and will be used for querying host names. Then we have two different DHCP options, which are additional information that will be transmitted to DHCP clients when the IP is assigned. In this case, we're telling clients what to configure as a default gateway and which DNS service should be used. There are a lot more options that we can set, but these two are the most common ones. Finally, we configure the DHCP range. This is the range of IP addresses that the DHCP server can hand out. Depending on your specific setup, you may want to reserve some of the addresses in your network for machines that need to have a static address. If you don't plan to do that, you can make the range larger, but make sure you don't include the address of the DHCP server itself. The last value in the DHCP range line is the length of the lease time for the IP address. In this case, it's 12 hours, which means that once an address is assigned to a machine, it will be reserved for that machine for those 12 hours. If the lease expires without the client renewing it, the address can be assigned to a different machine. Alright, we've gone through the configuration file. Let's tell Dnsmasq to start listening for queries using this config. So now I'm going to type in sudo dnsmasq dqc DHCP config and then hit enter. We can see in the output that Dnsmasq is listening for DHCP queries on the ETH_SRV interface with the options that we set in our configuration file. Now, let's run a DHCP client on a second terminal. So I want to open up the second terminal. Now on my second terminal, I'm going to type in sudo dhc client I eth CLI and then V for verbose. We're using DHC client, which is very common DHCP client on Linux. We're telling it to run on the eth_CLI interface, and we're using the -v flag to see the full output of what's happening. Back in the networking course, we explained the whole process of DHCP client getting a DHCP lease, and here we see the packets being exchanged and how our client got the IP address 192.168.1.80. We also see that the DHCP client expects to renew the address before it expires. Let's see how our interface looks now. So now I'm going to type in IP address show eth_CLI. Our eth_CLI interface has successfully acquired an IP address. Now, let's look at what Dnsmasq printed when the request was made. We see the same packet exchange that we saw from the client, but Dnsmasq also shows that it now knows the host name of the machine with the address 192.168.1.80. Because Dnsmasq also has DNS capabilities, this means it will also provide this as an authoritative answer for local queries. So now I'm going to type in dig at localhost instance 1. And with that, we've seen how Dnsmasq can act not only as a DNS server, but also as a DHCP server. This setup was a simulation to show you what you can do with Dnsmasq. As mentioned earlier, in real life, you would have this on separate machines, physical or virtual. If you want to test a setup like this, you would normally do that on a separate network from the production network. Remember, never test in production. We covered a lot of information in this module. You've learned about the overall services needed in IT infrastructure. On top of that, you learned about the physical infrastructure services like remote access and virtualization that help your organization run more efficiently. You even learned about essential network services like DNS and DHCP, along with the overall picture of what's needed to set up DNS for an organization and why you'd want to do that. And we've seen lots of these services in action. Now, we're going to let you practice with some quick lab exercises and test you on what you've learned. And don't forget, you can always go back and review the material again if you want before you take the quiz. In the next module, we're going to cover 2 of the other IT infrastructure services, software and platform services. I'll see you there.
Congratulations on finishing this lesson from the Google IT Support Certificate. Access the full experience, including job search help, and get the official certificate by clicking the icon or the link in the description. Watch the next lesson in the course by clicking here, and subscribe to our channel for more lessons from upcoming Google Career Certificates.